There we go. All right, so quadratics are really, really important in upper level math. I know that in Algebra 1, you probably were introduced to quadratic equations. Algebra 2, we're going to do a lot with them. And if you keep continuing on in upper level math, you're going to see quadratics pop up a lot. So when I say quadratic, what I'm referring to is basically any equation that has an x squared term. So the basic, most simple quadratic equation is y equals x squared. Is my screen sharing okay? Can you see that? Okay, all right. Okay, on my team viewer, it looks like it's still on a different screen, so I just wanted to make sure. All right, so this is like the basic, most simple quadratic equation. It's quadratic means that you have this x or the squared term. Okay, you can have other upper level equations, so you can have like y equals x cubed, but that's not a quadratic, that's a cubic equation. All right, so quadratics are really important, and they always have the same graph. So it's not going to be shocking anytime that you graph a quadratic equation. Anytime you have this x squared, unless you have something else kind of funny going on with your equation, you're going to always get a graph that is a parabola. Okay, so a parabola is kind of like a, I used to say bowl, but I don't know if bowl is really right. I don't really know. It's kind of this U-shaped opening thing here. So you're always going to get a parabola when you graph a quadratic. It doesn't matter if you have some other stuff at the end of your quadratic plus, whatever. And parabolas are cool because they belong to quadratic equations. Parabolas are also a really good graph to be able to recognize easily. Again, this is kind of one of those fundamental things. So knowing that that's a quadratic and that this is a parabola and they belong together is an important piece of information to have. Parabolas are kind of cool for a couple of reasons. One is that they are symmetrical. So this particular one happens to be symmetrical about the y-axis. Also, along this line of symmetry, we have this point here, which we call the vertex. And the vertex is simply the lowest value of your equation, or in some cases, if you were graphing y equals negative x squared, your parabola is going to open down, and your vertex is going to be your highest point. But there's always one vertex, kind of the peak, either the peak of the mountain or the valley of the mountain, right? And that's your vertex of your parabola. So then 4.1 was just all basically graphing parabolas to kind of get a feel for what they look like when you graph them. Graphing parabolas are important. So kind of let me give you the big picture where we're going with chapter 4. Chapter 4 is all about different quadratic equations and how do we solve them. I know that's exciting, right? How do we solve quadratic equations? And there's lots and lots of different methods to solve quadratic equations. However, the easiest method by far is actually by graphing. So we didn't specifically talk about this in 4.1. This is a little bit of new information. But if I said, so when we get into chapter 4, I'm going to say, let me do a, I'm just doing a little, I'm trying to find a good example that that works out nice and pretty for us. Here we go. Well, here we go. I'm kind of switching to 4.3 because we're skipping over 4.2. So 4.3, for example, if I had the equation, I'm picking one from your book. Giving you spoiler alert here. Okay, So this is number 5. And I'm going to kind of pull in concepts from several different sections. I'll start with what 4.3 is about, and then we'll kind of pull in a few other pieces of information, okay? So I have this quadratic. It's a squared plus, nope, a squared minus 13a plus 22. Okay, so this is a quadratic equation. So in 4.3, what we're doing is we're pulling out, I know that you guys had to do this in Algebra 1. I don't know how exactly you called it, but we're basically factoring quadratic equations. And I know in Algebra 1 we do a lot of this, but you know, it's one of those great fun things that we don't want to miss out on doing again. So what I mean by factoring is that we're going to break this down into another format that means the same thing, but kind of pulls our terms out. So we're going to have a factoring, we're factoring 2 different terms here. Okay, so in Algebra 1, you might be familiar with FOIL, which is a method of basically changing from a factored form back to a quadratic form. Right? You guys both heard of FOIL? Okay. Connor, did you do FOIL? Okay, just making sure. All right, so basically what I like to call is unfoiling. We want to go backwards, right? We want to unfoil, and then we have to check by foiling. Thankfully, this particular quadratic is pretty easy because we have just a plain old a squared here. So we know this has to be a times a to get our first term of a squared. And then how I like to do it to unfoil is I like to skip to the last number, okay? Last number in green. Our last number is 22. So I have to think about what 2 numbers do I put here to multiply together to get positive 22. So I can multiply 1 times 22 or 2 times 11. Yeah, that's pretty much it. When I decide between using 1 times 22 or 2 times 11 or the negatives of those, then I go to my middle term and say, well, what combination, 1 and 22 or 2 and 11, gives me 13? So if I put a 2 here and an 11 here, and I multiply 2 times 11, I get 22. So that takes care of my last term. But now I have to figure out, how do I get a negative 13a in the middle? So this is kind of a little bit of math, a little bit of kind of just looking at it and see what feels right. So to get a negative 13, I need to add together a negative 2 and a negative 11. And then when I multiply negative 2 times negative 11, I get positive 22. So there's not this like step-by-step process exactly how to factor. It's kind of a little bit of a, I mean, you kind of do it step by step, and then part of it's just looking at it and trying some different things out. Okay, so once I get a guess for my factored equation, then I go and I actually FOIL to see if I did it right. All right, so if I FOIL to see if I did it right, first is a times a squared. Okay, outside is a times negative 11, so then a. Inside is negative 2 times a, so negative 2a. And last is negative 2 times negative 11, so positive 22. So then when I add these guys up, I get a squared minus 13a plus 22. So I know I did a good job of my factoring. So this is my factored form. And when I say factored, my quadratic form and my factored form are the same. They're the same equation, they're just written in different formats. Okay. So that is 4.3. Now here's kind of the spoiler alert to 4.3 and beyond. Okay, so what this is all that most of 4.3 is asking for. I can't even draw a line. All right, here we go. Top half of the triangle is what it's looking for. We have, what if we took that original equation, a squared minus 13a plus 22, and I said that all equals 0. Can you solve this for a for me? Solve for a. Okay, so in algebra, we're all about solving for the variable, right? We're trying to figure out what's a, what's x, what's b. Can we solve that for a? Well, in the form that it's in right now, we don't have a whole lot of tools to solve for a. Like I can send 22 and 13a to the other side, but I still have a squared, and then I have to take the square root, and then that's kind of messy, and it's just not, you can try it on your own if you want, but take my word for it, it's kind of messy. The thing is, though, I also know that I can rewrite my quadratic as a minus 2 times a minus 11, and that equals 0. It's basically rewriting the same thing, and we do that all the time in algebra, right? We use the distributive property to write things without parentheses. We transform equations by multiplying everything by -1. So we're just rewriting the equation in a new form. Okay, well, why does this new form help me out? Well, this is where it kind of gets a little weird, right? So if I know that I have, this is my highly technical mathematical thing. If I know that I have something times something equals 0, okay? So I have one thing times another thing equals 0. That means that one of those two things has to be 0, right? Either this something has to equal 0, or this something has to equal 0. In order, when I multiply two things together, one of those two things has to be 0 to get an answer of 0. Okay, so either a minus 2 has to be 0, or a minus 11 has to be 0. Okay, and this I know how to solve. This is super easy. A minus 2 equals 0. That means when a equals 2, if I plug that back in right here, right? 2 minus 2 is 0, and 0 times anything is 0. Or this one, a minus 11 equals 0. That means when a equals 11, this is 0. So now if I go back all the way to the top, I know that this quadratic equation is true. It equals 0 if a equals 2. And if you plug this in here, 2 squared is 4 minus 2, 13 times 2. I'm going to do this on Desmos. I'm going to cheat here, guys, because I've been awake since late last night, so who knows what kind of math I'm going to do. All right. Sometimes you just got to plug it in. So 2 squared minus 13 times 2. Nope, see, I can't even type right. 13 times 2 plus 22 equals 0. Okay, or if I plug in 11, 11 squared minus 13 times 11 plus 22 equals 0. So those are my two answers. But wait, there's more. All right, so you remember this original equation is a squared minus 13a plus 22? A squared minus 13, I really want to type 12, 13a plus 22. I don't know if it's not going to like it because I did a. I have to change it to x. Okay. This is a, dun, da, da, da. Oh, very undramatic. It's too big. There we go. This is a parabola. So taking it back to 4, 1, it's a quadratic equation. So the graph of a quadratic equation always has to be a parabola, right? And what did we say that we wanted to find out? We wanted to find out when this equals 0. When does this parabola equal 0? I don't know why that changed it when I drew it like that. Don't type that in like that. That's kind of weird. We want to find out when does this equal 0? Well, basically we're saying when does the y part equal 0? So when does y equal 0? Y equals 0 along the x-axis, right? So when x is 2 and x is 2 or x is 11, those are the two times that my equation is 0. So that's kind of the full circle. Why do we care about the graph? The graph is actually the easiest way to find the answer to a parabola equation, even though I don't think they kind of point that out till later on. So that's kind of the spoiler alert for that. All right, so that's kind of full circle, everything we're going to do. Any questions about that? Do you need to see more factoring? Looks good. All right. Well, then we will keep trucking on in because next week is Thanksgiving week already. So we have class today, but we won't have class next Thursday. Is anybody doing anything fun for Thanksgiving? Yeah. You'll find out next week, huh? Okay. So 4, 4. Do you guys have 4, 4 in your notes, by the way? Okay. Just making sure. Okay. So 4, 4 is the same as 4, 3, except a little bit harder. Okay. So if you notice, if you did your 4, 3 homework yet, or if you didn't, in 4, 3, a lot of the problems are practice factoring. So you're just going to be like factoring like crazy. Basically, factoring means you're taking it from the quadratic and you're putting it in the two parentheses, okay? What you'll notice when you jump from 4, 3 to 4, 4 is that they have decided to give us a number in front of our squared term to make it a little bit more tricky to do our factoring. Okay, so up until this point, there was no number right there. So you just knew if you had n squared, you just knew it was n times n. Now we have a 3n squared, and that's going to kind of play into how we do our factoring. Okay, so let's just do a couple examples. It's just a little bit different. Like you have to think about the factors of both. Okay, so example number 1, we have 3n squared plus 7n plus 4. Okay. And we want to factor this. So still the same process. Oh no. Sarah, can you hear me? Am I back, Sarah? Can you hear me? Can you hear me, Connor? Okay. Is Sarah still there? Try closing some. Oh no, she can't hear me. Let's see. I might have her log back out and log back in. Okay, we'll give her a minute to do that. All right, Connor, take a 3-minute brain break. Okay, Sarah, can you hear me now? Okay. Yay. You're a little fuzzy, but I can hear you. It kind of sounds slightly like you're a robot. Hello, Sarah. All right. So we are going to factor, but what happens when they throw this number in the front? Then we just have to think a little harder. That's basically what we have to do. So we have a 3n squared in our first position here, right? So when we think of unfoiling, we have 3n squared. So the only ways that we can factor 3n squared are we can do 3n times n, or we could do negative 3n times negative n, but that's just mean. So we're just going to stick with 3n times n. So we know that one of these has to be 3n, and one has to be n. Okay. All right, and then our last term is 4. So the ways that we can make, and it's positive 4. So we can do 1 times 4. We can do 2 times 2. We can do negative 1 times negative 4. And we can do negative 2 times negative 2. Now, you don't have to write this whole thought process out every time, but I just want to kind of be specific about how I'm thinking through which terms to use, if that makes sense. Okay, so what I'm trying to do is in the middle, I'm trying to get a positive 7n. Okay, but now I have the kind of the complicating thing is when I multiply my inside outside, I have a 3 over here. So like, for example, if I use 1 and 4, right? I have to multiply 3 times 4 and I get 12. So I don't probably want to multiply 3 times 4. I probably want to multiply 3 times 1 or 3 times 2 because I'm trying to get to 7 and I don't want to get to 12. So not that. So let's try. Sometimes it's just trying. If I try 2 and 2, right? Then I do my outside is 3 times 2 is 6, plus 2 more is 8. Ugh, don't like that. So let's try. Let's try. Sorry, I was just looking at my notes here. Go back. There we go. What if we put a 1 over here and a 4 here? Okay. So I'm going to go with the positives. So positive 3 times 3n times positive 1 is 3n. And 4 times n is 4n. And 3n plus 4n is 7n. So this looks promising. So when I get to something that looks promising, I kind of mark it down, looks promising, and I check it by foiling. So I do 3n times n, 3n squared. So that's my first. My outside is 3n times 1, so plus 3n. My inside is 4 times n. And my last is 4. And these two add together to make 7n, so this is a check. Okay. So when you do your homework, I realize that this is kind of like, it's hard to always document because some people can like look at a quadratic and go to factor it and like it just pops out at them like, ooh, if I do this, it works. So like if you see something and it pops out, you don't have to sit there and write, all these factors out every time. If that's helping you through the process, of course, write it down. But I'm not going to be. Factoring is kind of like I said, it's math, but it's a little bit of an art of kind of like figuring out which numbers work together. I guess more of a math puzzle. I won't call it art quite art, but it's kind of a math puzzle of figuring out what works. It's not a step-by-step process. So if your step-by-step process happens in your head, it happens on the paper, it happens a little bit of both. I'm not like, if all you have written down is this, that's not necessarily bad. I mean, I trust that you're doing your homework to kind of think through the process. So I just wanted to mention that. So you don't have to feel like you have to write down every factor for every inside and outside, because that would take a really long time, because sometimes they just pop out at you. Like, for example, number 2. So number 2 is we have 4r squared minus 25. So the first thing that I notice about number 2, and whenever you get to a homework problem that is missing the inside-outside part, right? We don't have any just plain r. That's the only part. We don't have any plain r term in there. We have an r squared, and we have a constant, but we don't have anything. So the first thing that pops into my mind is that I want to use all of my squares of numbers. Okay? So that means I want to make sure everything is the same on both sides. So I have 4r squared minus 25, right? I want to make sure that, or what I want to do is I want to be able to cancel everything out. So when I go to factor this, I want my factors to actually kind of be balanced out. And these numbers are like setting off alarm bells in my mind. So, side note, full of side notes today. Your squared terms are going to be really, really important to memorize when you do factoring. And so even if you don't memorize them, to have a sheet that's sitting there with all of your squared terms, really helpful. So what do I mean by that? What I mean is just to know that 2 squared is 4, 3 squared, 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on. Okay, so when you see one of these numbers over here and you're doing factoring work in chapter 4, alarm bells should be going off in your head like ding, 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 ding. Okay, 4 is 2 squared and 25 is 5 squared, and I'm really thinking that that's probably going to be part of my factors. Not always a guarantee, but that's a really, really good kind of signal if you see a perfect square, especially if there's nothing in the middle. So what I mean by that is I know that 4 is 2 squared. So I am going to just first guess off the bat, say that it's 2r times 2r. And 25 is 5 times 5. So minus 5 times plus 5 gives me negative 25. Okay, this is going to be my first guess. And so you can see, I mean, I wrote this over here because I was explaining perfect squares, but I didn't actually show any work when I went from green to black here, right? I just kind of like, ooh, I know 4 is a perfect square, and I know 25 is a perfect square. So I'm just going to kind of guess this is my first guess. The reason that I kind of had this hunch is because I know that I cancel everything else out in the middle. So when I FOIL this, right, 2r times 2r is 4r squared, okay? Outside is 2r times positive 5, so 10r. Inside is negative 10r, and yay, they cancel out. And then my last term is negative 25. So these guys cancel out, and ta-da, I have factored it. So you would see if you're doing number 2 for your homework, you wouldn't have a whole lot written down, but it's kind of just knowing, oh, those are perfect squares, and I need to be able to move, to use those perfect squares. Okay? Is that making sense? Looks so fun, right? Can't wait to factor. Sometimes they're not factorable too, and that's kind of like, you're like, what? That's not cool. You're not allowed to do that. Okay, I'm gonna skip down a little bit. Let's try 4 and 5. So 4 and 5, when you look at number 4, it's like, ooh, 12x squared minus 4x minus 40. That looks fun to factor. How many factors of 40 are there? A lot. 1 times 40, 2 times 20, 4 times 10, 8 times 5. Lots and lots of factors. And then 12 has a bunch of factors. I don't really even want to do number 4. That doesn't look fun, right? That's what I would be thinking if I was doing my homework. All right, so let's look at this a little bit more closely, though, because if you notice something about everything in number 4, they kind of all have something in common. So I have 12x squared minus 4x minus 40. Okay, and it's interesting. 12, 4, and 40 all have 4 in common, the number 4 in common. So you actually are allowed to pull out 4 from this quadratic separate from your factors, because 4 is just basically multiplying everything in there. So what I mean is I'm going to basically reverse distribute. I'm pulling out my 4, right? So when I pull out a 4, I pull 4 out of 12x squared and I get 3x squared minus, and then I pull a 4 out of 4 times x, so minus x, and I pull a 4 out of 40, 10. So now my second equation, although not super pleasant, looks a lot easier to factor than 12 and 40. Now I just have a 3 and a 10 to deal with. So that helps me out, right? So you just leave this 4 out front because it's just multiplying the whole thing, right? And then I'm going to factor. Okay, so 3x squared, the only way to make 3x squared is to do 3x times 3. So I know that my first term has to be that. On the back side, I have a negative 10. So I have a couple options. Negative 1 times positive 10, or 1 times negative 10, right? I also have negative 2 times 5, or positive 2 times negative 5. So I need to figure out what combination basically cancels everything out, because all I want left over is a negative 1. I am going to guess, since these numbers are bigger, I probably want to go with something in this family of the 2s and the 5s. Okay, so if I multiply 3 by 2 and then 5 by x, that's interesting. 2 times 3 is 6, and 5 times 1 is 5. So 6 and 5, if I kind of subtract them, I get 1. Now I just have to figure out which sign goes where. Okay, so I want my bigger number to be negative. So that means I want 6 to be negative and 5 to be positive. So this is my first kind of guess. So how do I check it? Our good friend FOIL, once again, right? So 3x times x is 3x squared. Ooh, 3x squared with a really big x. My outside term is negative 6x, and my inside is positive 5x, and my last term is negative 10. So negative 6 plus positive 5x, negative 6x plus positive 5x is negative x, and that works out. So this is my factored form of my equation. I know you guys can't wait to do this. All right, what would happen up here? I should have set this up. What would have happened if I would have actually switched the signs? So if I would have had 3x minus 5 and x plus 2, when I FOILed it, I would have gotten 3x squared plus 6x minus 5x minus 10. So when I FOILed it, I would have gotten a plus x, not a negative x. And so if you're ever doing factoring and you get to your FOIL step and you get the right middle term, but it's the wrong sign, if it's the wrong sign, that probably means you just need to flip your signs in your factoring in most cases. All right. Let's do, are you guys excited to get started with this? Can't wait, right? Actually, I think it's kind of fun. Of course, I'm a math teacher, but I think it's kind of fun. When you figure it out, it's like figuring out like a Sudoku or something. You're like, yes, I figured it out. Or maybe that's just because I'm a math geek. I don't know. All right. So take it a step further. Last few problems. Now we have some quadratics, and now they equal 0. So we're up until this point, we're just factoring. So now we're going to factor with an actual purpose, right? So number 6 says 14s squared minus 21s equals 0. Kind of looks like 215, but that's an s. Okay. So how do I factor 14s squared minus 21s? Yep, that's one thing I can definitely do. Is there anything else I could pull out, Connor? What about s? They both have an s in it. Yeah. That's awesome that you recognize that, though, because I do not like using s's because I look like 5s. Here, I'll make the number really big and then the letter small. There we go. What if I pulled a 7s out of both of them? And so that's really good that you recognize that, Connor, because a lot of people, even I think the first time, I've done this problem enough now that I know it, but I was kind of like, oh, how do I solve this? I don't have a last term. And I was like, oh, they both have 7s in common. I can just pull that out. Okay, so if I pull a 7s out of both of those, I'm left with 2s, because 7s times 2s is 14s squared, minus 3 equals 0. Okay, now how do I solve this? This is the fancy something times something equals 0, so one of those two somethings has to be 0. So either, and this is a something times something equals 0, right? I have 7s times 2s minus 3 equals 0. So either 7s, it has to be 0, or 2s minus 3 has to be 0. Okay, so if 7 times s has to be 0, that means s could be 0, right? Over here, 2s minus 3 equals 0, so add 3 to both sides. Hold on a second. Here you go. All right, add 3 to both sides. We get 2s equals positive 3, or s equals 3 over 2, which is the same as 1.5. So the two answers, the two solutions to my quadratic are s equals 0 or 1.5. Okay, so we're going to kind of full circle it here. So let's take this equation and plop it in Desmos, or take my quadratic and plop it in Desmos. So it was 14, and it doesn't like s, so we have to use x. 14x squared. Oh, was it plus or minus? Let's see. Minus 21. Minus 21x. And we want to know where my equation equals 0. Well, my equation equals 0 when x equals 0 and when x equals 1.5. All right, so those are my 2 zeros in my equation. And one more just for fun. Let me see if I have them. Okay. There we go. Number 7, we have 4s squared. Why am I using s again? Man, I need to fix my notes. Oh, it's a s and an x. That's going to be really hard to solve this equation since I have 2 different variables. Let's just try to change this to 4x squared minus 20x. Typo, plus 25. So the first way that it's oh, sorry, go ahead. No. Well, it could be, but not given the information we have. Yeah. Yes. So that was a total typo. Okay. So are any alarm bells going off in your head about the numbers here? I have 25. It's a perfect square. And I have 4. It's a perfect square. I'm so excited. I think I'm going to get to use my perfect squares again. And unfortunately, it's the same exact example. But my first guess when I factor this, well, first of all, you might notice there's a 4 out front, a 20, and a 25. Can I pull anything out? No, right? Because I could either pull a 2 or a 4 out, and 2 and 4 don't go into 25. So I'm stuck with just factoring like it is. All right, so I am going to just guess my perfect squares first. It's always a good strategy because if they show up, they're likely to be used. So in order to get a positive 25 at the end, but a negative in the middle, I probably need to do negative times negative to get my positive. So I'm totally just going to guess this based off of the fact that it's a perfect square. And then if it doesn't work, I'm going to go backwards, work my way back. So now I FOIL to check it, right? First is 4x squared. Outside is negative 10x. Inside is negative 10x. And last is positive 25 equals 0. Negative 10x plus negative 10x is negative 20x. And woohoo, I factored it. So this is right. Yay. Okay. Now what happens if by something times something is the same thing? All right. Well, that means that either 2x minus 5 has to be equal to 0, or 2x minus 5 has to be equal to 0. They're the same exact thing, right? When I solve this, I'm going to get x equals 5 over 2. X equals 5 over 2. So I only really have one answer. That's kind of weird. So the answer to this equation is x equals 5 over 2, or 2.5. So whenever I kind of get something weird like that and I want to double check, or if I just want to double check my work anyway, let me pop it into a graphing tool. Okay. So I have 4x squared minus 20x plus 25. So this is why. So look at my parabola, right? The vertex of my parabola hits right on the x-axis. So in this particular case, this quadratic equation actually only has one solution because my quadratic only equals 0 one time because it just hits right there at the vertex, right? And it is when x equals 2.5 or 5 over 2. Pretty cool, huh? For math, you know. All right. Then, well, yeah, we'll leave it there. Eventually, we're going to learn what happens when your parabola. So when your parabola is, let's see. When your parabola looks like this, right? you have 2 answers. And you can have at most 2 answers to a quadratic. Okay, so the most solutions that you can come up with is 2, and that's due to this squared term. Okay, and then you could also have 1 solution. And I'm just trying to think how to force this. No, that didn't work. Let's see. Ooh, maybe this will work for me. Where's my parabola? Oh, look at my parabola now when I move I've changed my quadratic around. What's the answer to this? What x's make this true? It's a trick question, right? And never hits the x-axis down here. So for this particular quadratic equation, that means number 1, you won't be able to factor it no matter how hard you try. Can't factor it. Number 2, it means that we would say this has no real solutions. We are going to learn that there are actually a solution to this, but it's in the complex number field, and complex number is that number. We have I, the imaginary number I, which we'll get to talk about soon. Everybody loves when we talk about imaginary numbers. But for today, we're going to live in the world of real solutions and real factoring. So all of these, you should have 1 real factor, and some of them they might not be factorable, but that's the fun that is 4.4. So thank you guys very much. I know this is a long class today. I appreciate it.